You're recording. Okay. Oh, I guess I'm on that. All right. Where's it going? Oh, yes. Let's see, what are we doing today? Here. Let's see what we're doing today. Today. We are. Where we at?
3.4 is due tomorrow night.
Today was 2/13, right? Yeah, I don't know.
Yeah, because it was, I don't think upgraded, because we just turned in one
Okay,
yesterday.
okay. Yeah, whatever the days are on Alex, that's where they're kept.
Okay.
So I'm gonna pop in there now. Do you have any homework questions? Do you have any problems you want me to do?
Yeah, word questions.
Yeah, if you have any, let me know. I'll pull them in. I can pull them in. Well, let me get into Alex then. Assignments. Oh yeah, I wanted to see while I'm here. Of that. I put that thing at. There it is. All right, anyways, today is 2/13. This week, it looks like I've got to get through 3/6 through 3/8. So it's going to be 3/6 is going to be painful. I'm sorry to tell you, because it's word problems. So we're gonna work probably 3/6 today, and then 3/7 and 3/8 I'll probably do on then. But then next week is our first test.
Okay, and what section that's gonna be on?
It's, look on the syllabus right there. It tells you in yellow exactly what's being covered on the first exam. Yeah,
It's the 22nd.
right. So we'll have a review on 2/20.
Okay, we'll have a review.
So 3/6 is slated for today, 3/7 and 3/8 is slated for Thursday. Believe me, we'll have plenty to do today. I'll have more than enough problems to do this. So the word problems are a pain, but we're all gonna be dealing with one version of it. So let me first, questions, do you have any? Do you have any questions? No? I hate these blank last pages. I gotta fix that. Oh, I get it. Okay. So spring break is directly in the middle week for a full semester. Okay. What was your question?
Trying to get there.
Where am I at here? I'm gonna close that. I don't need that thing up. Close that. Don't need this up. What's this one? This, oh yeah, you're gonna try to find me something?
Yeah.
I think unless they have a problem that I'm looking for. Okay. Sections are gargantuan, aren't they? How many pages are these things?
This, I don't know what you want to see.
No, go ahead. You got anytime. I'm just getting to the homework area so I know what kind of problems I want to do.
I brought it in last time, just let you see it.
I don't remember the name of the title of this, that's word problem, it has application, but I don't know the word. Whenever you see that word, that means word problem. First, we want to talk about something called a ratio. So it comes in various forms. You might see it looking like this. Or you might see it looking like this. You know, these are, usually you say something like A to B. You know, you always have like guys considering where to go to college. He might do a little research and say, hey, the ratio of girls to boys is a certain amount. He might be interested in a higher ratio of girls to boys, not like the exclusion. We use ratios a lot of times when we're cooking. When you're measuring out ingredients, things like that. I'll show you what I'm talking about in a minute. But usually, everybody does this nowadays. When you're going to learn, do you all cook? At all? So if you want to find out something new to cook, do you go on YouTube and look it up? Or you find a recipe online somewhere? Rarely is the recipe online going to be the exact number of people that you have. So you either make the recipe as it's written, which means that for 4 servings, you're making 4 servings, or you adjust it for your situation. So what do we do here? Consider the recipe I think you would use 2 1/3 cups of flour.
Cake.
That seems like, yeah, flour. Yeah. I never make cakes. That seems like a lot. Let's call it flour. So we have a recipe, look it up, 2 1/3 cups of flour. And unfortunately, you need to serve 6 people. And the recipe of that. So what do? We set up something called a proportion. You heard this phrase before? Heard the word proportion before? That's where you set 2 ratios equal to each other. So let's set this up. I'll show you the term. Let's do the solution. set yourself up for proportion. The way I usually tell students to do it is you want to keep track of the things that you're interested on either in the numerator or denominator of a fraction, and then what is to be found in the other spot. I know that makes no sense, but here's what I'm gonna do. I'm gonna do this. I'm gonna do the number of flour, the amount of flour divided by the people. So what I mean is this, we know that 2 1/3 cups of flour serves how many people? 4. We are serving how many? 6. We want to know how much that is. See what I'm saying? This is our proportion. Yeah, this is our price. Now, do you know how to solve these things? Do you know what you do to solve something like this?
You can go times 2, you can times 6 times 2.
Right, so this is, do you remember what this is called?
I think I figured it out, but I don't know if it's the same way.
Do you know what this is called? And this 4 times x. 4 times x, the other side, is 6 times 2 1/3. Now, I'll tell you this right now, you don't want to be multiplying a mixed number. They're not made for doing much of anything with except looking at them. So I will convert my 2 1/3 to 7/3. So I'll look at it this way, I'll have 6/1 times 7/3, and that equals 4x. Now luckily, I can do this. So I'll have 14 is equal to 4x. To finish it off, I would divide by 4. I'll simplify this a little bit. X is equal to 7/2. I don't know about you, but I've never read a recipe that lists it in that units like that. What do you do? I'll change it to a mixed, back to a mixed numbers.
I did it a little bit differently.
All right, give me 1 second, we can talk about that. 3 1/2 cups is what we needed of flour. Go ahead.
So I know that 6 is like half of double the 4. So then I just I changed 2 to 1, 2 and 2/6.
Yeah, you can do that, that's fine. And I recognize that too, I go, this is just 1.5 times the original, so I would just take 1.5 times. But that doesn't exactly show the proportions. And this is what we're gonna be dealing with, this right here. Let me show you how it works. The mathematics behind it, because it's really cool. I think it is, but you know. What we have is this, suppose I have A over B equals C over D. Now, one of the ways of clearing out fractions from an equation is to multiply by the LCD. So I'm going to multiply both sides of this equation of B. I think C is nowhere near what I want. I want B times D. So I'll do B times D over 1. I'll do the same thing over here. Now, on the left side, the B's cancel, and you're left with A times D. On the right side, D's cancel, and you're left with B, C. So go back to the original equation. AD equals BC. So these proportions are really, really important. They solve an unbelievable number of problems in real life. We'll just start grabbing a bunch and see what happens. You guys caught up? Caught up? Okay. All right, so let me, you show me, demonstrate to me that you can do one of these things. And maybe I'll grab a more, well, we did credit, the first one I did was not exactly a beautiful looking one, so go ahead. There are more efficient ways to do these than I'm doing. I don't care about that though. It's not like you're gonna start doing this with your profession right today, so. I could have just multiplied both sides of the equation by 3 and been done with it.
That's good.
But I didn't bother, so I want to just, it's the same thing every time we solve these things. Did you all get 4? Did you all get, I mean, did you get this equation first?
Yeah, yeah.
Okay. And then work it out. So you get- It's going to be an easy problem to solve after you make that initial cross multiplication. Let me see if I can find a more sinister looking one. Here we go. These are looking better. All right, let's do that one for 38. Why did you do that? Why, you don't have to get there. You don't have to count it on there at all. Just cross multiply. First step, cross multiply.
So, yeah, it's,
Right, so circle that, circle it. You're gonna multiply it too. Sure, you can see what you're doing. at the row line, not through it, put a circle around the board, and then like I'm doing on the board, so I can see, it's connected.
It's 32 studies.
Gotcha, all right, now I follow, okay, so 20, that's, you don't need that, get rid of this, get rid of the 20s, you don't need. The whole idea behind cross multiplying is to get rid of fractions. How to solve it? It's just an equation now. You're trying to figure out the value of that.
Okay, so I'm,
Add 36 to your normal business. T equals 3. Right, let's take a look. This is one, the reason why I'm gonna pull this one out is you gotta be a little careful what you multiply here. You did it correctly, but you didn't show this stuff explicitly. So I'm gonna do it explicitly here. You take this whole thing times 4. So that's gonna be 4 times 8t minus 9. That's in the parentheses. And then this thing times 3. And then I'll distribute this through. Okay. Yeah, the mistake that people generally make is they don't multiply, they don't do the distributive part.
I subtracted the 36 from the.
Oh, instead of added? Oh, okay. Well, then everybody's on the same page then. I'll just finish it out for those who need it. I don't think there's 4 people in this class, by the way. Because one person never shows up. So there's almost every whole class. Oh yeah, the reason I mentioned this is because somebody, at least one other person's not here, they can watch this video later, so these steps are needed. Then divide by 32. We get T 3. You feel comfortable with this, you want me to grab another one like this? Yeah. Grab another one, right? I'll just go through the motions here. How much you're doing? 10 feet. 90. 50. 90. Five by 10. Okay. Next topic is something called a unit rate. You're familiar with these if you go to the store and are trying to figure out how much a quantity is per, say, ounce. Like if you buy, what would you buy though? You buy the ounce, well, flour, for example. They might say it's $2.59 for, I don't know, 32 ounces of flour. Question would be like, well, how much is that per ounce? Or, I mean, that's the thing you would look for. Let's say when you shop, usually the case is, the situation is, if you buy more of an item, you pay a lower rate for it. So like flour, perhaps is in this side, maybe it's, I don't know, 30 cents an ounce. But if I buy a super size, that you find in Sam's Club and places like this, maybe 15 cents an ounce. So this is cheaper. Not always practical though. You know what I'm saying? Anyways, where do you get that when I just said 15 cents an ounce, 30 cents an ounce? Where is that information stored at?
Price divided by,
If you look at the price, usually, not always. I know that drugstores do this all the time. They'll show you the unit price on the sticker where it's priced. You look carefully, it'll say so many cents per ounce or something. They do that, not every place does that. So am I correct in that when you buy two identical items, that you're interested in which one's the better value? The better value has a lower unit price. So let's do the unit price first of all, or the unit rate. A unit rate is a fraction with a denominator of 1.
is the denominator at the top or the bottom?
Bottom. Oh man, I didn't click on it. All right, let's take a look here. Cat litter, that's a good one. Let's do cat litter first. I'll do one and then I'll give you one to do. It'll be similar, of course. You serious? You know, this might not make sense to somebody who's looking at these notes without the instructions before it. So let me grab those too. I will tell you, I mean, I have a pet peeve about especially soda pop. Unfortunately, as a society, soda pop is kind of what people drink, isn't it? So when you go to the store and buy soda pop, what do you always have to do if you're a soda pop buyer? If you want to save money, you've got to buy like 30 of them. It'll say something like 5 for so much money. I go, but if you buy them less than that, the normal price is what takes place. So here, what we want to do is we want to know the price per pound. That's going to be our setup. So we do this. Price. This is what we're going to want here. So on the one hand, we have $8.48 divided by 1, and that, not, how many, 30 pounds. And this is dollars per pound. So, what I'll be down here. Okay, so here's what you do. Take out your calculator. Take your machine out. This is gonna be, all these are gonna be machine problems, unless you like doing long division by hand. I wouldn't recommend it then. So, take out your calculator, how much you get? 8.48 divided by 30.
28 cents per pound.
I might want to go more decimal places than that.
Oh.
Give me a second. I'll tell you, I'm gonna write some up here and then we'll discuss the rounding and stuff like. Now, obviously, rounding to 2 decimal places is a smart idea, right? Because when you're talking about prices, they come in 2 decimals. So here's, let me see what my machine says. I have 8.48 divided by 30. And I'll tell you what, I'll put it down on my machine. I'll go to 3 decimal places. And this is per pound, so this is the way you'll see it written on the label. They usually even go another decimal place on the stores. So that's how much that one is. Do the same for the other one. So this time I'll take $12.98. And I'll divide it by 50 pounds. Now, if it works like a normal store, this is gonna be the cheaper one. I get 2.596 for this one, and it stops. It stops, so I just did it all 4 places. Which of these numbers is smaller?
50 pound.
20, that one's, it's a little, just a slight bit less than 26 cents a pound. So this year is the better deal. So the better deal has the lower unit price. You may not know this, but by doing this division, you know what you technically did? Technically put this over 1. That's why it's a unit price. So we've got the better deal mapped out, better unit, the lower unit price is the better deal. This is us down, we're not playing any games like I have a smaller version of 1 and a different kind of brand that's bigger, that doesn't count. This is, you're making this decision. You don't care, the difference doesn't make any, they're the same. Just to you, is it more convenient or not, is the price better? So I would, if I had the money, I would be purchasing the 50-pound one instead of the 30-pound one. Now, there's 2 things that you gotta think of too, when you buy this stuff, like, you keep thinking, like, one time I went to Sam's or BJ's or whatever, one of these stores, and I got a giant jar of mustard. So it was the size, you've seen them in baseball or at stadiums, right? You ever see the big yellow jars of plastic jars of mustard? Got one. Well, what happened after about a year it went bad? So we didn't use it. Ended up throwing it out. So there's that to count for too. So cat litter will not go bad as far as I know. All right, I'm gonna give you one to try. So you see, it's not, there's nothing really to it. They're gonna try 3 varieties here of applesauce. Oh.
Which one is this one here? This one. Oh. Guys are doing the biggest correctly.
So I'll go out to as many places as I have to determine which one is better than the other. You know what, in this one, you could have gotten it at just 2 places. Well, technically, yeah, you could have. Because 2 places, that would have been 11, the second one would have been 10, and the third one would have been 0.7. So you still would have been able to tell which was the better deal. Any questions about this? The prices are very simple, very useful. You should always take a calculator with you to the store. Luckily, you do that.
Are you gonna ask us to round off?
I think they might possibly, but, you always have your cell phone with you, and it has calculator. Of course, now they make it more fun at the store, you know, you can get the pricing gun, you ever see them? It'll keep track of the things as you buy them. It'll tell you how much you're gonna pay when you get there. Never do that with kids. It'll destroy whatever you think. They'll price everything in the store. All right, what am I gonna do? What's that? Yeah, exactly. And then whatever numbers are on that thing are meaningless by the time my kids get done with that thing. All right, now we're ready for some word problems. Good, I got about a half an hour to do these. Well, okay, we'll do number 48. This is like the one I did to motivate today's lesson. Let me fix it. I cut it. Where's my delete button? Let me redo that. Space. That's right. 1.5 divided by X. Get the bottom half of this fraction. 0.75. For a line under that. Put an X, because that's how much you want to know. The quantity you're looking for. So once again, I urge you to make yourself a little primer, I guess you might call it. This tells you how to set up your fractions. So it doesn't matter, as long as you're consistent, you'll do it correctly. So the way I did it, salt was listed first, I did salt divided by soda. That's what I'm going to be setting up. So we know that salt to soda is 0.7521. And we are there, but they tell us the amount of salts, they tell us the top of the fraction, they do not tell us the amount of soda. I'll pause there. let you digest all like that. I realize sometimes I just kind of ramble for a while, so I'll calm down a little bit. Do you guys understand the setup? Salt divided by soda, yeah, go ahead. Now, you could be upside down. You just don't want to do one and then flip it somewhere else in the problem. Yeah, that's not fun. All right, so let's go through this. I wouldn't bother making, if I were you, here's what I would do. I wouldn't even bother with fractions at all. I'd probably do this. You know? Why bother? It's maybe part of it's decimal anyway. All right, let me go ahead and cross multiply them. So I got 0.75 times x. And then I don't have, this one's nothing, this is 1.5. And then divide by 0.75. Now, I wouldn't get so cavalier with this changing fractions into decimals. Just, the only reason I changed it was because there was going to be a decimal in the problem. But you'll run into an issue with, like, if the decimal and the fraction goes off forever, then you can't write it as a decimal because you've never had the exact value. We good there? Okay, let's do another one similar. Yeah, these are the kind of things you hear on the news all the time. They tell you how much caffeine is in that drink. This is extremely easy, but this is one of those rare situations in math where you don't even have to lift a pencil if you know what to do. But set it up like you do. I'm just going to do it anyways mathematically. But I still want you to set up the proportion. Can anyone see the answer is 120? Just by looking at the question. I'm still going to do it. But we'll set up, make sure you can do it both ways. 8 ounces gives us 80, right? 12, that's 10 per ounce, right? 10 milligrams per ounce. Times 12, 120. But now to set it up in the proper proportion, we do need practice at proportions, even if the problem is super easy. Set up the proportion, make sure that you can do the steps. So what I would probably do in this case, we have an 8 ounce serving and 80 milligrams of caffeine. So I'd probably do ounces divided by milligrams, like this. Got 8 over 80 equals 12 over x. That's pretty simple. I mean, it's not like the problem is undesirable even in this format. It's not so bad. Cross multiply, we have 8x equals 18, and you see 960. And divide by 8. Now don't forget your units. What is this, ounces? No, milligrams. Any questions about that? Proportions, for some reason, as word problems are concerned, students do better at those than most other types.
Let's see how high they go, so I know. Oh, great, they go up to 100, excellent, okay. Want to make sure I do at least one of each of these things. Okay, about that. Here we go. This is something that used to be a big deal. Did you guys keep maps, any of you in your cars? With the phones, you kind of don't need them, but unless you're out of cell phone service, I still do keep some maps in my cars, just in case something like that happens to me. So this used to be, what they do on the maps is they tell you, they have a little thing that says 1 inch represents, say, like a mile. Have you heard that phrase before, or something like that? And so that'll give you an idea. You can estimate how long something is going to be by looking at the map. So go ahead and see if you can do this.
Inches and miles.
Inches to miles. That's what I do too. I actually, I did mine upside down, but it doesn't. Inches. Divided by miles. 1 inch is 120 miles. 3.5 inches is how many miles? For us. If I'm not mistaken, this number equals 420. Yep. Whereas work policies are pretty nice, aren't they? They're not so bad. They do get worse. These are all set up in the same way. We have other problems that are similar in nature, but not quite set up exactly the same way, but they all follow. All of the problems in this section do have a common theme to them in their structure. I'll pop back to here. I'm gonna let you play around with the rectangle, the triangles guy. I'm not sure I have much time, but do you know how many angles, if you add up all the angles inside of a triangle?
It's 180, right?
Yeah, I'll tell you how to do one of these since, because what they're using is a proportionality to solve these things. You don't need to know the angles. My bad.
Is it 180 or 360 though?
180. It's 360 inside of if you add up all the angles and say like a rectangle. All right, so I wanted to determine the value of X. Let me show you how it's done. Do you see those little symbols? Do you see the angles inside of there? They got 1 notch, 2 notches, or 3 notches. You see that? That means that the one triangle and the other triangle have the same exact angles in the same places. Do you see it? The top angle is the same, the middle angle is the same, and the bottom angle is the same. So one has been blown up, or if you want, one has been shrunk down. Make sense? So I took the first one and shrunk it down. Now I want to figure out that value of X. There's a beautiful relationship in mathematics. These things have a name. They're called similar triangles. Have you ever heard that phrase? All of yours will have similar triangles. And they have all sorts of proportionalities that you can do. And these triangles, when they're similar, make them plural. When they're similar, you can take and set as a proportion ratios of the corresponding edges. So what I'm talking about is this. I can take x divided by 24 and set it equal to 18 divided by 9, since they are talking about the same two sides. You understand? Let's pause that again. I'll try it again. I can do, say, x divided by 24 is the same as 18 divided by 9. You know what else? X divided by 13 is the same as 18 divided by 12. You know what else? 24 divided by 32 is the same as 9 divided by 12. That's the beauty of similar triangles. This is what I mean by corresponding sides. So when I have that, and you can switch these two, 24 over x is the same as 9 over 18. So I'm going to use any one of these. There's at least 4 different equations I could grab. I'm going to set up this one. X over 24 equals, so x over 24, 18, 9. Then cross multiply. And then divide by 9. Now I'm going to do something I don't normally do. Check this out. 9. I'm not going to bother multiplying this out because I'm going to do this. So all of yours will involve similar triangles. So I showed you and kind of talked about it. If you get stuck, of course, you can ask next class, but you'll have some of these, I think. Okay. That's a result from geometry you were not expected to know before you walked into this class. All right, money. Money is always a big deal with people. I don't want to do that. No, I don't. Let's do here. Danica. Let's take a look at Danica. So my game plan now is to do as many different types of word problems so that you'll have a fighting chance against this homework. They have nowadays, if you go to the bank with a jar of pennies, they can dump it in a counter. Did you know that? And they count cash too, dollars. I mean, they have a machine for that as well. So they don't have to count anything by themselves. So what do we have? Danica has pennies and nickels in a jar. One day she counted them and found that there were 131 coins worth $3.43. And how many pennies and how many nickels were in the jar? So what we could do is, let's see here. One day she counted and found that there were 131 coins worth $3.43. Okay. How much is a penny worth? 1 penny. So these pennies are worth 1.01. If you want to do it, that is a determination we'll have to use, oddly enough. But we could say this is 1 cent. Nickels, what are these things? 5 cents. They're so small, I don't even know what they're worth anymore. I see pennies on the ground all the time. People don't even want them. They weigh them down. So yeah, so keep that in mind. This will come into play. Let me show you why. It will come into play right here. I either need to decide if I'm going to work in dollars and cents or in distant cents at this point. So if I leave it as 3.43, then I will change those to 0.01 and 0.05. Or I can make this a little bit easier on myself and make this 343 cents. Now I don't have to worry about decimals anymore. I'm all done with them. So you can, there's more, like I said, there's more than one way to do this. If you decide to go with the decimals, you should get exactly the same answer. So what do we have here? We have pennies and nickels. So I have 1 penny is worth a cent and, okay, so let's see. Let's do P equals the number of pennies. Oops, I think I lost track. Can you come up with an expression then for the number of nickels?
And
Try not to use another
P
letter.
times 5,
Try not to use another letter.
or P times 5.
It would be times 5, that's for sure. But I don't want to go to another letter.
Yeah, so P.
I can't use P. I don't know that there's the same number of pennies as nickels.
Yes.
When I read it, I'm hoping everybody go, oh, yeah, yeah, yeah. Let's see if that is in fact true. Search your heart, you know it to be true. How many coins are there total?
131.
131. Some of those are P, the rest of them are the N's. So you don't want to break out 2 variables just yet in this course. We'll do that later on. So the equation that I have then is I have the number of pennies, I have P pennies, plus now each of these nickels is worth 5 cents. So I'm going to multiply it by 5. And then we know it's 343 cents. So there's the pennies. Here's your nickels. And you solve this like you would anything else. Well, distribute the 5 through. So P plus the 5 distributes through to both parts. 5 times 131, I think, is 655. We good? Okay. Now I'm going to combine those P's on the left. So on the left, I have 655 minus 4P. That's equal to 343. Next one. Don't everybody yell out one.
You want,
Yeah, I had a question mark at the end of that last one. What do I do next? 655, subtract 655, right?
It's 5.
No, 1 minus 5 is 4. So then here we got 3. Well, is that
Yeah.
negative 3? Well,
Yep.
now, when you do the word problem, the answer should make sense. And if negative numbers start coming up, you should start to panic. I would suspect, like, what do you mean? There can't be a negative number or something. Well, the negatives will cancel when I divide by -4. So 80, 78, P is 78.
Yeah.
So we have, this is equal to 78, 78. So we have 78 pennies. How do I get the number of nickels?
131 minus 78.
That's right, 131 minus 78. Let me move that up. 131 minus P, then is equal to
33.
53 nickels. You would, if I were you, I probably would check it out just to make sure it actually adds up. Take these things and multiply it by 5, you get 250, 65, $2.65, and then add 78 cents. It should come out to 43. Word problems are especially desirable to check, I would think. So in a problem like this, a negative number would have been absolute impossible. That can happen sometimes. Then you just say there's no answer, or like there's no, let's do one of these rate ones. 82. One of the problems that makes people nervous is those old problems from when you were young, like one train leaves one place and one train leaves another place. And well, this is one of those problems. We're going to be making use of a single formula that is so important in the world and in mathematics. I can't overestimate it. You guys know this equation. I'm not even going to say what the letters stand for because most people would know what they are, but I don't know at your level if you're familiar. Have you guys ever seen this before? Distance equals rate times time. Distance equals rate times time. That's exactly right. So this is as long as the speed doesn't change, this is what happens. It's what they call uniform speed. So distance equals, we're going to make use of that formula over and over and over again. In every problem that deals with distance and moving and stuff like that, we'll use this formula in one way or another. Let's take a look at what we have. We have two planes leave San Francisco. One is flying north and the other is flying south. They're going opposite. Okay. The southbound plane travels 50 miles per hour faster than the northbound one. After 2 hours, they are 900 miles apart, flying the speed of each plane. So the speed of each plane. So let's start with the north plane. Let's just say it's going X miles per hour. Can you tell me how fast the south one is going? To X plus 50, right? X plus 50. Okay, so after 2 hours, they are 900 miles apart. So let's see, we got 900 miles apart. So here's the distance equals rate times time. It doesn't always look directly like it. That's what I wanted to warn you about. What's the total distance they're covering, these two? 900 miles. So I'll put the 900 in for D. Now they're traveling at two different speeds. So the first guy, the northbound plane is going X miles an hour, but he's doing it for 2 hours. Isn't that true? R is the X and T is 2. So this is the northbound plane. This is the north. Plus the southbound plane, which we know to be the rate is X plus 50. And it was also flying for exactly 2 hours, wasn't it? Yeah, by now it should be natural what you do. What am I gonna do next?
Find X.
I have been before that.
2X plus 100.
Right. This is exactly right. So we're gonna have 900 equals 2X plus 2X plus 100. I can combine my 4X's, my X to get a 4X. 900 equals 4X plus 100.
So X equals 200.
Right, subtract 100. And then divide by 4. Now answer the problem. How fast are the planes going?
200 and 200, was it 250?
250, right? So the north one, that's one that was going X. That's 200 miles per hour. Actually, it's 2 mph for that. South, it's 250. I heard something, you might find interesting. I'm done with class, but I want to tell you something I thought was interesting. In America, you know, we're one of the only countries on the planet that doesn't use the metric system, at least not to our knowledge. It's used by Americans, believe me. You look at your bottles of water, it's listed in metric. They just have to put ounces on it to make us happy. Do you know why it failed? What a big reason was? Changing our signs on the highways. Every single thing that refers to miles per hour would have, or miles would have to change, wouldn't it? Everything with miles and metric is time, there's no such thing as metric time, it's all the same. So they would have to change all the miles to kilometers everywhere. Even those little posts or little things that you pass along the way with the tenths of a mile on them, you know?
Right, but I'm still curious as to why they chose to drive on the left side of the road.
Oh, those, oh, geez.
That's what I'm like.
Who started driving? Well, America did, right? No, they would have had vehicles in World War I, right? But they wouldn't have used the roads, I don't think.
No, I mean, the roads that they would have used back then, I assume would have been up dirt.
Yeah.
Like, well,
I don't know, you know, sometimes people choose things just to be different from somebody you don't like. And that could possibly be too.
I mean, it doesn't work.
People are petty sometimes like that. Governments can be.
Oh, man.
So we got something to do tomorrow.
I think so. Go ahead. Alex has the dates. Yeah. I'll post this thing. I'm gonna go ahead and close this and post it, the notes right now. I'll cancel this.
Yeah, right.